Time is more real than space. Smolin is a theoretical physicist whose work has been defined by a rejection of what is known as the Copenhagen Interpretation of quantum mechanics, the study of how the smallest known things behave. The distinction of the Copenhagen interpretation is that it fully accepts the weird, I would even use the Japanese word kwaidan, behavior of the fundamental constituents of reality. Yes, it is spooky. But quantum mechanics still works. This point of view, that it works, is also called operationalism. Albert Einstein rejected the Copenhagen interpretation, stressing, again and again, that the celebrated quantum weirdness was the result of our ignorance, our inadequate knowledge of quantum scale phenomena. Once we have a hypothesis informed by a deeper understanding of reality, then the ghosts would evaporate and a hard connection could finally be established between events that are large and those that are extremely small. Smolin's goal as a theorist has been to do exactly that, make Einstein's theories reach into the quantum realm and replace the theory of quantum events that depends on ghosts and human participation. It is in this sense that Smolin is a realist. He wants the world to be out there and possible without humans being there. Reality must stand on its own. With the Copenhagen interpretation, it does not. The task to bring the hard and large reality of stars, trees, and tables, the classical mechanics reinterpreted by Einstein in the early 20th century, with the ghostly mechanics described by Werner Heisenberg and Niels Bohr in the mid-1920s is no easy task, and by all accounts, it seems Smolin, as brilliant as he is, has found no way out of the established interpretation, or operationalism. Nevertheless, in the process, he has discovered an idea that's truly startling and revolutionary. During the last decade, he described the different aspects of the idea in 3 books, the most recent of which was published in 2019, Einstein's Unfinished Revolution: The Search for What Lies Beyond the Quantum. The idea is simply this: space emerges from time. What this means is that space is an illusion, and time is real. And so without time, space would not exist. How is it possible to think in this way? It seems very wrong-headed. But it's not at all. The more one considers the idea, the more sense it starts to make. In the Einstein's Unfinished Revolution, The Search for What Lies Beyond the Quantum, Smolin writes: Space and time cannot both be fundamental. Only one can be present at the deepest level of understanding, the other must be emergent and contingent. This seems ultimately to be forced on us by the non-locality of entanglement, which leads to a tension between realist approaches to quantum mechanics and special relativity. I would then like to suggest that the tension is resolved by making one of the pair space-time fundamental, while the other is an emergent and approximate description, ultimately a kind of illusion. I choose to focus on the hypothesis that time is fundamental, while space is emergent. The thing that time fundamentalism resolves is the phenomena in quantum foundations known as entanglement. This is when the states of particles interact in such way that their quantum properties are no longer independent. They are connected, even if separated by a great distance. Einstein famously denounced entanglement as spooky action at a distance. But it's as real as concrete or a loaf of bread or a toothache. It happens, and we can do nothing but live with it. Indeed, scientists in Scotland even managed to take the world's first photo of quantum entanglement in 2019, though this story did not make as much noise as the photo of the black hole. The problem that quantum entanglement presents to a theorist is that of space. It is a non-local event. Meaning, it is indifferent to space. Or, put another way, it operates as if space does not exist. You can't even call entanglement fast. It does not move. It happens in time without extension. And so positing that space is emergent, Smolin, whose thinking along these lines was influenced by and developed with the Greek theoretical physicist Fotini Markopoulou, the Brazilian philosopher Roberto Mangabeira, and the Portuguese cosmologist Marina Cortes, is able to explain quantum non-locality as a consequence of defects that arise from spaceless relations that are present prior to the emergence of space from a time governed by these principles. It's causal, it's irreversible. Smolin writes, the process by which future events are created from present events can't go backward. Once an event has happened, it can't be made to unhappen. Space is emergent. There is no space, fundamentally. There are events and they cause other events, so there are causal relations. These events make up a network of relationships. Space arises as a coarse-grained and approximate description of the network of relationships between events. The implications of this idea are profound. To give just one example, Paula Marchesini argues in her 2018 paper The End of Time or Time Reborn, that the problems in Smolin's idea of the primacy of time can be cleared if Henri Bergson's concepts of time are adopted. Although there are a number of things that are solid in Marchesini's argument, the paper nevertheless fails to overcome my feeling that it is the other way around. The metaphysics of time formulated by Bergson at the beginning of the 20th century are actually enhanced by Smolin's temporal relationism. Bergson thought that what is most real is the movement of time, or duration, and what's an illusion are moments in time. But philosophy and science have privileged frozen time, moments, over a time that is pure movement. According to Smolin, time is fundamentally durational, relational, dynamic, causal, and is the ticking and ticking when space is not there. In fact, this radical demotion of space presents a way for rethinking one of Bergson's theoretical preoccupations, the nature of memory. In his 1896 book Matter and Memory, Bergson distinguished between two forms memory. One that is habitual, merely functional, and therefore not philosophical, and another that is pure recall, a process Bergson calls image remembrance, and is therefore spiritual. Despite influencing the greatest novel ever written, Marcel Proust's remembrance of things past, et la recherche du temps perdu, there is nothing really that interesting about Bergsonian memory, and it's a little too mystical for my taste. But if we were to consider memory in the context of Smolin's idea of time, which makes space illusory, the first thing that goes is the Bergsonian distinction between utilitarian memory and memory that's basically loafing around. Everything is memorized, and it is this memorization that, no matter what it's doing, recalling the words of a beloved dead person, remembering a recipe, it is always amazing. And what does Smolin's concept of time make possible, in regards to a new philosophy of memory, the meaning of this longish post? That it shares some of the features of quantum entanglement. Memory is essentially non-local. What dissolves with a new philosophy of memory is precisely space. The present in the past becomes present in the present. Memory is only about past nows rotating in the mind with actual nows. The 17th century Dutch philosopher Baruch Spinoza had some idea of this when he described images from the past as being present to the imagination. In the 26th proposition of his Ethics, Spinoza wrote that the human mind will regard an image from the past as actually existing, or as present to itself, until the human body be affected in such a way as to exclude the existence or the presence of the said image. Chronologically, a present, or now, might be fixed in the past. But when it is reimagined, memory is not pure but creative, it is no longer in the past. Why? Because the space between the time has dissolved. Space is the ghost in the machine. The deepest question that leaves us with then is this: if space were fundamental, could there be memory? Article by Charles Mudede. Time is more real than space. Smolin is a theoretical physicist who